A good way to understand this is to look at the bladeless fan that was introduced by Dyson in 2009. Even though the first patent in this space was by Toshiba in 1981, but Dyson was the first to create a commercial product. It is said that the bladeless fan multiplies the air by up to 15 times. So let's have a look at how thrust augmentation or air multiplication happens. If you look at the bladeless fan, it has a small compressor that is hidden away in the stock of the fan. So the name bladeless is actually a misnomer. The blades are just on the inside rather than the outside, which has its advantages that will be revealed later. The compressor pushes the compressed air to a toroidal outlet through a tiny slit opening, thus creating a narrow jet of air. This outgoing jet of air encounters a diverging surface in its path. Now fluids have a tendency to follow the profile of the surface in their proximity. This is called the Coanda effect. So the air jet, instead of flowing straight through, follows the profile of the diverging section. This creates a negative pressure in the middle of the propulsor ring or tube, which encourages air in front of the propulsors to be inducted and pulled through the hoop. This step is called air induction, and it alone can bring up to 10 times more fluid in the stream than was released from the slit outlet. But there's also a second step that adds a little more air. This is called entrainment. Going by the definition, entrainment is the transport of fluid across an interface between two bodies of fluid by a shear induced turbulent flux. Or in simple words, entrainment is when a fluid, in our case air, is pulled into an existing stream of air and cannot escape because of the circulation or vortices at the flow boundaries that trap the air. It is not that the fluid induction or entrainment technique hasn't been successfully used before in the aviation world. It has been, but in a totally different application. There is a device called an aspirator that is used to fill up the evacuation slide in a passenger aircraft and works on flow induction. Note that it is extremely difficult to inflate the slide rapidly by an air pump alone, and we just cannot install a massive size air pump for this purpose. So the aspirator is used, which sucks air from the ambient as the compressed air jet is being pushed into the slide. And because of this, the evacuation slide inflates in a matter of seconds. Another application is the eductors in ships that pump out flooded compartments. In the event of an accident, seawater is pumped to the eductor and forced through a jet, and any fluid at the inlet of the eductor is carried along to the outlet and up out of the compartment.